going to show you step by step how to graph a polynomial that is in factored form. This is a little easier than if it was in standard form. I haven't got to that yet. So when it's in factored form, you can easily see your x-intercepts, since remember, factoring is a way to find x-intercepts. So that's where I'm going to start, with my x-intercepts and then their multiplicities and what is happening on the graph at each of those x-intercepts. So what you would do is set each factor equal to 0. That includes the negative x squared in front. Some people forget about that one. Make sure everything containing an x is set equal to 0. So for the first one, if you have negative x squared equals 0, x has to be 0. If x plus 2 is equal to 0, moving the 2 over means that x is negative 2. If x minus 1 is 0, moving that negative 1 over means that x is 1. Next is the multiplicities. Just think of the multiplicities as how many times does this factor occur? In other words, what is the exponent on that factor? So for the first x-intercept, we got 0. 0 came from negative x squared. Negative x squared has an exponent of 2, which means its multiplicity is 2. Next, I've got negative 2 as my x-intercept. That came from x plus 2, which has an exponent of 1. We just don't write it. So the multiplicity would be 1. Same thing applies with x minus 1. That's where 1 came from, and it has an exponent of 1, which means the multiplicity is 1. Now, when you have an even multiplicity, the graph is going to bounce at that x-intercept. If you have an odd multiplicity, the graph is going to cross through that x-intercept. So because I have a multiplicity of 2, it's going to bounce at 0. And the other multiplicities are odd, so that means the graph is going to cross through negative 2 and 1. If you're unsure of what I mean by bounce and cross, you will see when I graph it at the end. Next, we're going to find the y-intercept. So I went ahead and rewrote the equation again. When you want the y-intercept, that means x is equal to 0. So you're going to replace every x with 0 and simplify. If you want to pause the video to do that yourself, go for it. So replacing every x with 0, I'm going to end up with everything being multiplied by 0. So that means it must equal 0. So the y-intercept here is just 0, 0. Next, we're going to go on to the end behavior, which is dependent on the leading coefficient and the degree. The leading coefficient here, I'm more just worried about the sign of it, whether it's going to be positive or negative. So if you look at the equation, there's a negative in the very front. So if I were to convert this to standard form, I'm going to have a negative leading coefficient. So I just put an arrow there to show you that that negative in the front is the reason why this is a negative polynomial. Next is the degree. Now, if this was in standard form, you would just be picking out the highest degree. However, this is not in standard form. But what you can do is just take your multiplicities and add them together. When you add your multiplicities of 2, 1, and 1, you end up with 4. Now, what I'm worried about with the degree is whether it's an even or an odd number. And since we have a degree of 4, this is going to be even. So these two things are going to help me with end behavior. We just found that this is a negative even function. Whenever you have an even degree, the ends of the graph are going to be facing the same direction. Whenever that even polynomial is negative, They are both going to be facing down. So your end behavior, x is approaching negative infinity, means what is happening on the left? Well, on the left where I just drew it, the graph is going to be going down. Going down means y is approaching negative infinity. All of your y's keep getting more and more negative as it goes down. The next part, x is approaching positive infinity, means what's happening on the right. Well, again, I just drew it. On the right, the graph is going down, so y is also approaching negative infinity on the right. If you struggle with end behavior, there's a video about end behavior where I explain the notation. Now that I have everything, I'm going to go ahead and sketch it. I went ahead and I put my x-intercepts on the graph already. Where I like to start is my end behavior. So on the previous slide, we found that both ends of this are going to be going down. So on the left and the rightmost x-intercepts, I'm going to draw the graph going down. Now I'm going to fill in the rest of it. So we found that we had even and odd multiplicities here. I'm going to go back to the slide because it's been a while. Okay, we said that the graph should bounce at 0, but it should cross at -2 and 1. So going from left to right, the first x-intercept I run into is -2. I just said that this should cross through -2. So starting with that left side that I just drew, I'm going to have it cross through the x-intercept instead of bouncing off of it and coming back down. So kind of like that. Now eventually this is going to have to come back down and reach my next x-intercept. If you want to know exactly how high this goes, you could plug in -1 if you want to see what the y value would be, but I'm just doing very rough sketches here. So again, it's going to go up and then come back down at our x-intercept of 0. And I said that it's going to bounce at 0. So instead of crossing through and going below the x-axis, it's going to bounce back up. So it's kind of like that. Again, these are very rough sketches. Now, once it bounces back up, it's going to have to come back down and reach my last x-intercept. And we said that it should cross through that x-intercept, which makes sense because it does cross through in order to reach that other end behavior that we drew.